Supply chain volatility extracts a massive financial toll from enterprise operations. The average Fortune 500 company loses $184 million annually to logistics disruptions. Contrasting that standard loss, AI-native networks generate a compounding return, crossing the year 3 marker at the 300% threshold. This growth stems from 3 metrics: up to 31% cost reductions, 40% better delivery reliability, and an 18-month break-even. Relying on passive observation to manage supply chain disruption is an increasingly expensive strategy. We are seeing a transition from productivity AI, which focuses on saving planners time, to operational AI. This new class of technology directly removes physical friction from the P&L. The mechanism driving this shift is agentic AI. These autonomous, multi-agent systems identify disruptions and immediately execute the necessary recovery workflows without requiring human intervention. These organizations are not using AI as a simple dashboard for forecasting. They are using it as an autonomous orchestration engine that spans the entire value chain. To understand how these returns are achieved, we must look at 3 operational layers. First, dynamic logistics. Second, autonomous inventory. And finally, predictive maintenance. The 150 to 250% returns seen by enterprise leaders are generated by replacing manual exception handling with autonomous execution. Physical freight movement is naturally vulnerable. Once a truck leaves the distribution center, it is at the mercy of traffic, weather, and infrastructure failures. Static route planning cannot account for these real-time physical conditions. This lack of agility inevitably results in poor asset utilization and excessive fuel consumption. Dynamic routing provides the solution. Ingesting live telematics, the system constantly reevaluates the path upon detecting a disruption, shown by this red zone. It calculates thousands of permutations in milliseconds, locking in an optimized green route that bypasses the friction. The agentic system also re-optimizes and consolidates loads mid-transit to ensure trucks do not run with empty capacity. Walmart provided verifiable proof of the system's efficacy through a large-scale deployment. Walmart's AI routing eliminated 30 million unnecessary driving miles and prevented 94 million pounds of CO2 emissions. These physical metrics resulted in a 22% drop in transport costs and a 40% improvement in asset utilization. Dynamic routing proves that autonomous navigation is the only mathematically viable way to shield transportation margins from external volatility. Inside the distribution center, inventory management is a constant trade-off between the high costs of carrying stock and the operational risk of a stockout. Multi-echelon inventory optimization addresses this by viewing the stock as a fluid network rather than static piles in isolated buildings. Machine learning algorithms now replace rigid safety stock rules. Evaluating hundreds of variables, the system predicts demand waves with 95% accuracy. It autonomously rebalances stock across different geographic echelons, equalizing levels so no building reaches a stockout or overstock state. This agentic layer directs autonomous mobile robots on the floor to execute the most efficient pick paths for this balanced inventory. At this scale, robotic orchestration is saving Amazon an estimated $4 billion annually in fulfillment costs. DHL reports a 99.7% order accuracy and a 35% increase in productivity after integrating these AI-driven systems. Replacing manual ordering with autonomous inventory orchestration transforms the warehouse from a rigid capital sink into an elastic asset. Any inventory optimization is useless if the physical machinery running the supply chain fails. Logistics throughput depends on asset availability. A failure at a single constraint point creates a bottleneck that ripples across the entire network. Traditional maintenance is inefficient. Companies either run equipment to failure, shown by the red line, or follow wasteful schedules that pull machines offline prematurely. Predictive maintenance changes this by using IoT edge sensors to identify micro-patterns of vibration long before mechanical failure. When an anomaly is detected, the system autonomously triggers a maintenance event, ordering the necessary parts and scheduling a technician without human prompting. This eliminates reactive firefighting and the unnecessary downtime caused by rigid, scheduled maintenance plans. These systems routinely reduce unplanned downtime by 30 to 50%. A construction firm using predictive AI generated $210,000 in annual savings. a figure paying for the entire system 3 times over in a single year. Maximizing asset uptime through predictive monitoring is a prerequisite for maintaining consistent supply chain throughput. The maximum returns in logistics are found through cross-functional orchestration. This diagram shows the agentic control tower. Data from logistics, inventory, and maintenance feed into a central hub, where AI agent nodes are instantly intercepted and resolved before they reach the human oversight layer. This intelligence layer filters out standard operational noise and executes corrective actions instantly, allowing human operators to focus on true systemic risk. Successfully implementing these systems requires a phased approach rather than a single wide-scale integration. Because autonomous agents rely on integrated data, a disciplined deployment strategy is required to ensure the foundation is stable. Looking at the implementation timeline, Phase 1 focuses on foundation assessment and launching a targeted pilot within 3 months. Phase 2 executes quick wins like route optimization to fund complex integrations. By month 18, the system breaks even, scaling to 3D digital twins and full warehouse automation. Agentic AI acts as a decision acceleration layer. By embedding these systems directly into their execution frameworks, organizations lock in cost structures that traditional competitors cannot match.